These are the 0.6b notes for PreCalc. We're talking here today about parallel and perpendicular lines. So parallel lines, we know, are lines that never cross each other. So they look something like that. In order for that to happen, they have to have the same slope. So example 1 says, show that L1 and L2 are parallel. So pretty much all we have to do is compare the slopes. So right here in L1, the slope is already available to us because that's in slope-intercept form. However, for L2, we do need to solve for y, change it over to slope-intercept form, y equals mx plus b, in order for us to be able to find the slope. Subtract 4x. I'm going to put my negative 4x first, only because it comes first in that equation, followed by the minus 18, and then divide by 6. Reduce the fraction negative 4/6 down to negative 2/3. And divide out the numbers at the end, minus 3. Now that we have that in slope-intercept form, we can see that that is our slope. And you can see that the slopes are the same. And that's all we need to do is just show that they are parallel. We just need to show that the slopes are the same. For example, number 2, find an equation that is parallel. So instead of them giving us the two equations, they're giving us one of the equations, and our job is to find the other one. So in order to do that, we have to first be focused on our slope. So for our first line, we're going to find the slope. 6x plus 3y equals 15. And we're going to do the same thing we just did for that L2 problem. Subtract 6x. Again, I always like to bring that x first and then the constant number at the end. Divide by 3. Negative 2x plus 15. And I'm going to take this slope right here. And because it's parallel, I want to use the exact same slope in my problem up here. So that's going to be my m. And then this is going to be my x1 and my y1. So we found the slope of one line, and we're going to use that to do our next equation. Y minus y1. Let me write that equation out for you in case you don't have it. So when we worked on yesterday, our point slope form, we're just plugging our numbers in. Distribute. Solve for y. And there we go. There's the other equation. And you can see that they both have the same slope, which means they're both going to be parallel lines to each other. All right. Now we move on to perpendicular lines. For perpendicular lines are things that cross at 90-degree angle. It's always going to be like that. And in order for them to cross exactly at a 90-degree angle, they have to have opposite, meaning the signs, 1 plus, 1 minus, opposite reciprocal slopes. So opposite, positive versus negative. Reciprocal is just, remember, when you take that fraction, you flip it over. So for example 3, let's just find the perpendicular slope. They give us a slope, and we're going to find the perpendicular slope. You just have to change the sign and flip it over. So 3 halves, the perpendicular slope would be negative 2/3. Negative 1/5 would end up being positive 5 over 1. Let's just leave it as positive 5. Negative 8, any whole numbers, go ahead and put the 1 underneath there. Positive 1/8. And again, put the 1 under there. When we flip it, we get 1 over 0. And remember, we're not allowed to have a 0 in the denominator. So when that happens, you would say undefined. Remember, your slope of 0 looks like this. And then your undefined slope is up and down. So those are, in fact, perpendicular to each other, 0 and undefined. Now let's work through those equations again. This is just like we did in example number 2, except it's asking for perpendicular. So first thing we need to do, find the slope. Y equals negative 1/3 x plus 2. And this one's nice because it's already in slope-intercept form. Here's my slope. Now we're not going to use the same slope because they want perpendicular. So we're going to have to change this over, change the sign, and do the reciprocal. So that's going to give us a slope of 3. It's going to be our m. Here we have x1 and y1. And then we can just plug them in. Make the double negative a positive. Distribute. And then subtract the 2. There we go. On the back side, we have 2 lines as well as 2 tables that we're going to talk about. So how can I tell from a graph or from these tables whether the lines are parallel, perpendicular, or neither? In order to do that, we are going to need to compare the slopes. Always compare the slopes. So for example 5, we have 2 lines. Let's talk about this top line first, the one that crosses through 4. We're just going to try to find the slope of this. Looks like it's down 1 and over 2, so that'd be a slope of negative 1/2. And then we're going to go to the other one and try to find that slope. So I'm going to walk up 3 over 4. Looks like a slope of 3/4. So they're obviously not parallel. I can tell from just the picture they're not parallel. But perpendicular, did they cross at a 90-degree angle? It doesn't look like it, but I can tell from my slopes, because they're not the reciprocal of each other, that they are not perpendicular, which means that these are neither. All right, for example 6, we're going to do this table. The table's written a little funny. Normally it's written kind of up and down. This one's more off to the side. And if we need the slopes of the table, we're going to have to find one at a time. So table 1, you can pick any points on the table that you like. Just remember they are ordered pairs x, y. So I'm going to pick maybe 3, 0, and 4, 2. And I'm going to write it just like points. And then I'm going to label x1, y1, and x2, y2. And then we could do our slope formula. If you forgot what the slope formula is, I'll write it off to the side here for you. And we'll just plug these numbers in. All right, so I found a slope of 2 for table 1. Let's do the same thing for table 2. Think about it, it works no matter which points you pick. So if one of you picks 0, 6, 1, 8, and then somebody else wants to pick 3, 12, and 1, 8, it's all going to work. It doesn't matter which points you pick. So let's pick 1, 8, and 3, 12. x1, y1, x2, y2. See if you can find the slope of that one. So you would have 12 minus 8 over 3. You can come in if you want. It's up to you. Your call. I'm just making this quick video, so I'm almost done with it. Sorry about that. 3 minus 1. All right. That gives us 4 over 2, and that gives us 2. And you can compare those slopes right here. You can see that those are the same. And if they are the same, it means the lines are parallel.